In this video, I'll show you how to construct the hello world of PUMA microscopes, that is, the foundation scope. The foundation scope is the simplest fully functional scope that can be built from PUMA modules. It uses a mirror for illumination, so does not require any electronics. The main limitation of the foundation scope is that it lacks a condenser, so can't give good images with high power objectives, anything over ×10. However, the U in PUMA stands for upgradable. The PUMA Abbey condenser module may be added at a later time, as may any other upgrade, hence the term foundation, because from this scope you can build and upgrade to the most complex of PUMA research scopes as required. These are the parts and some of the tools you'll need to build the PUMA foundation scope. The PUMA Z stage is common to all PUMA microscopes, and a separate tutorial shows how to build this. A link is provided in the video description below, so I won't repeat that here. For the 3D printed components in general, prior to construction, you must first remove any structures that are not part of the functional model itself, such as bed adhesion pads or supports and any stray plastic strings, etc. First, we assemble the adjustable mirror illuminator. Glue the mirror glass onto the mirror holder. When doing this, take care not to cut yourself on the mirror edges, because these are unfinished sharp glass. Also, take care not to get any glue on the mirror surface, especially if using epoxy, as I am doing here, because this can be very hard to clean off when set. Next, clip the lugs in the mirror holder into the sockets in the mirror suspend structure. And insert the M4 screws on either side. Only tighten enough so that you can still move the mirror angle in the sockets, but that the mirror stays where you leave it. That is, it doesn't flop around due to gravity. Put the mirror assembly to one side for now and allow the glue to set. We now prepare the filter block assembly. Insert an M3 nut into the recess of the front lug at the top of the filter block barrel. Use an M3 screw and washer to pull it all the way in. Now attach the lower two filter slots and base thread to the filter block with 4 M3 screws, each 14 mm long. Orientate the filter slots with the openings facing the back of the filter block and with the filter rim facing downwards. Hold these against the filter block with the flat part of the base thread. One of the 3 lugs of the base thread has a groove in it. Orientate the base thread such that the grooved lug is to the front and just to the right of the top lug on the filter block barrel. Insert the 4 screws, taking care to ensure that they are fully inserted, but do not over-tighten. These are metal screws going into passively cut plastic threads, so you can easily damage or destroy the thread if you over-tighten. Now insert 3 M3 grub screws into the quick release objective holder from beneath where the indented channels are. Screw them up till they are just below the top surface of the quick release holder. Then thread the quick release holder onto the base thread of the filter block assembly till the grooved lug on the quick release holder lines up with the grooved lug on the filter block base thread. At this point, you can screw the grub screws up another 2 mm so that it locks the objective holder in place. Now that the filter block is assembled, ensure the quick release mechanism is cleared of any small 3D printing imperfections by passing the assembly in and out of a quick release trainer a few times to get a free but snug click fit. Be careful not to cross the threads when doing this so as not to damage the quick release mechanism on either the filter block or the trainer. Finally, prepare the objective holding RMS thread. The first thing to do here is ensure the C thread in the quick release objective holder is clear of any obvious plastic blebs or strings using a sharp knife. Once clear, train the thread by making some careful passes in and out of the thread using a metal male C thread, such as a C thread extension adapter or the thread of a 25 mm objective lens. Take care not to cross the plastic thread in the quick release objective holder while doing this. Ensure that any plastic dust from this procedure is cleared away before proceeding. Once the plastic female C thread in the quick release objective holder is clear and well trained, you can insert the C to RMS thread adapter into the quick release objective holder. A 3D printed plastic version of this adapter is available as part of the PUMA open source standard, but today I am using a commercial metal version. You can insert this by first attaching the C to RMS thread adapter to your objective lens. Then use the objective as a handle to insert the adapter. Again, be very careful not to cross the thread, or the adapter and any objective you subsequently insert into it will not be aligned correctly to the optical axis of the scope. Now attach the legs to the stage. For the foundation scope, the short legs will suffice, so we attach the 20 mm spacers to the front 2 legs and then the plastic feet onto the spacers. If the 3D printed surfaces of the feet are too slippery, you can fix that by sanding the undersurface of the plastic feet to give them a bit more grip. They can be made even more grippy by coating with a rubber paint if required, but obviously you would do that prior to assembly and ensure any coating is dry first. The hind leg of the stage can have its plastic leg screwed directly to it without a spacer, so that the scope tilts backwards for a more convenient manual viewing angle. But if you require the scope to be level, for example, when using a fluid-based specimen in a cavity slide, then a 20 mm spacer can also be added to the hind leg. Now turn the stage upside down and attach the mirror to base plate module to the undersurface using two M4 thumb screws to the back two M4 holes around the specimen hole as shown. The pre-prepared Mirror Illuminator can now be clipped into this holder and rotated to a convenient position. Turn the scope the right way up. Note that you have two axis positioning freedom for the mirror. Make sure the mirror glass surface is cleaned prior to use. You must only use a diffuse light source that is safe to view. Never get a direct or specular reflection of the sun in the mirror when viewing by eye, and likewise avoid using other light sources that could permanently damage your vision, such as laser pointers. In addition to the objective lens of your choice, the above-stage optics for a foundation scope consists in the Simple Filterblock with its two filter slots, the monocular tube, and a single ocular holder assembly with an ocular lens. In order to prevent stray light from entering the optical tube via the filter slots, you should have filters occupying the slots at all times, even blank filters. These filters will also act as additional baffles to minimize internal reflections in the optical tube. Note that the filters have a top surface with an abrupt edge and a bottom surface with a beveled edge. The top surface also has some marking on the filter handle. Be sure to only insert filters the correct way up so as not to damage the filter slot channel. Begin by inserting the lower filter. Take care not to let it cross over into the top filter slot. Once this has clicked in place, insert the upper filter. The filters can be removed at any time by placing your thumb and forefinger either side of the optical tube just in front of the filter handle and gently squeezing against the tube while applying backwards pressure to the filter handle till it dislodges from its clicked-in position. You can then pull the filter out completely. Screw the monocular tube into the filter block till finger tight. Avoid excessive tightening so as not to damage the plastic threads. Screw the ocular extension onto the monocular tube all the way that it can go. Again, avoid over-tightening. Now thread the ocular lock nut onto the ocular extension tube and the ocular cap after that till it reaches the lock nut. Adjust the lock nut position so that there is a 2 mm gap between the top of the ocular cap and the ocular extension tube. The ocular lens can now be push-fitted into the aperture. If there is resistance, then you can twist the ocular barrel. If there is still too much resistance, then remove the monocular tube from the filter block and use some fine sandpaper to sand the aperture. But be careful not to widen the gap too much, because the ocular lens is held steady by friction alone. If you do use sandpaper, be sure to clear away all traces of sandpaper grit afterwards, or these could fall onto the back of your objective lenses and damage them. To remove the grit, disassemble the parts and use an air duster or wash the parts in water and allow to air dry without heat before reassembly. Using heat to dry the parts could cause shrinkage and lead to worse problems. The final step before attaching the optics to the stage is to fit your objective lens to the lower end of the tube. Attach the above stage optics to the focus plate by means of the quick release mechanism. To do this, first note that the final position of the optical tube will be with the filter slots facing the back of the scope. Start by inserting the optical tube at about 90 degrees anti-clockwise from this position, ensuring that it is perpendicular to the focus plate and not at an angle, or there will be a risk of crossing the quick release thread. Apply gentle pressure downwards, gravity should be sufficient, and rotate by 90 degrees clockwise till the attachment lowers and clicks into position. Take care not to force the fit. If the tube is at an angle and the threads are crossed, you could break these thin bridges in the connector. Check that there is a gap of more than the thickness of your specimen between the tip of the objective and the level of the stage platform. For a standard microscope slide, this gap should be more than about 1.5 mm. If the gap is too small, raise the Z stage via the focus gears till a large enough gap is made. Now slide your test slide under the objective, resting it flat against the stage all the time, so as not to risk contact of the glass slide with your objective lens and so damage it. When in position, attach the two stage clips to hold it down, as shown. The foundation scope is now complete. If you like this video, please give it a thumbs up and support the open source PUMA project by hitting the big red subscribe button. If you have social media accounts, also please share this video on those accounts using the YouTube share button. Thanks for watching.